Hey guys, welcome back to another week. Today we're doing page 478, 1 through 8, and 17 through 22. We're almost at the end of the chapter here. Um, Today we're talking about the graphs for square root functions. Um, it's going to be kind of a short and sweet lesson here today. What I put on the board is kind of number 9, which I did not assign, but it kind of gives us an idea of what's going on here. What I want to do is graph f of x equals square root of x. So I went ahead and made a table and chose some x values that are going to plug in to the function and then see what I get that comes out. And then I'm going to graph the function over here to see what it looks like. Okay, so I chose -1 for my first x value. What is the square root of -1? Well, the square root of -1 doesn't work very well because what times itself equals -1? There isn't really anything that it's going to work for that. So this is not a real answer, and that's kind of important for later. If you have a negative under the square root, it's not real. Okay, so I just put that one up there to say it doesn't work, so we can't graph it. We're going to kind of we'll throw that top one out. Okay, but what happens if I plug in 0? What's the square root of 0? What times itself equals 0? 0. So that means on our graph there's going to be a point at 0, 0. So I'm going to graph that later. Okay, if I plug in 1, square root of 1, what times itself equals 1? If I plug in 4, what's the square root of 4? If I plug in 9, what's the square root of 9? Okay, so all these that I plugged in worked out nice and neat. You don't have to use these square numbers here, but they just work out nicely, and I don't want a bunch of messy decimals, so that's what's going to happen. All right, 0, 0 was my first point, right at the origin. 1, 1, 4, 2, and 9, 3. I went all the way out to 9 here. So if I drew in the lines between those points, it would look something like that. So it has a end point over here at 0, 0, kind of rises kind of quick at the beginning, and then it slows down as you keep going. So that's what a square root function looks like. If you think about it, kind of makes sense. The square root cuts numbers down quickly, so the bigger you get, the slower it rises. Anyway, that's what a square root function looks like. Well, later on, we're going to be guessing what the function looks like based on some tricks we know. Do you guys recall when we graphed these functions a couple chapters ago? I don't know, however long it was. Normally an x squared function just looks like this. Okay, there's a point at 0, 0, and it just goes up on either side. But if you do a -3 on the x and a +1, that like shifts the graph. What the -3 does, it affects the x motion, but it always does the opposite. So it actually moves the graph right 3. And a +1 out here affects the up and down, and it does what you might guess. It moves the graph up 1. Hopefully you guys recall that. The same thing is going to be happening today on our graphs. And this really applies to the last section. So anyway, that's how it works. The same tricks we used 2 chapters ago are going to apply today. So this was a squared function, x squared function. Today we're doing a square root function, but those same ideas of right 3, up 1 are going to apply. 1 through 8 doesn't really have anything to do with that, though. So let's go ahead and jump in. I'm going to do the odds with you again. Jump into number 1. Number 1 looks just like my example here, just says square root of x. The question is, determine the domain of the radical function. That means domain is what can the x values be. And normally on a function, the x value can be anything, but a square root function has a problem. There's something that the square root makes not work, and that would be negatives. So x can be anything other than negative. Or whatever's under the square root can be anything as long as it's not negative. So in this case, it can't be -1, -2, -3. So how am I going to show that? Well, as long as it's 0 or higher, it's going to work. So the way we're going to show that, and this is number 1, the domain x can be anything greater than or equal to 0. Okay, so that would just be the answer, the end. Okay, number 2, I know that's an even, but let me do a problem like number 2, and then hopefully you'll get it. Says, so remember, under the square root, it needs to be at least a 0. So what x value would make x plus 5 0? Well, what plus 5 equals 0? -5 plus 5 equals 0. So if x is -5, it's going to work, but also if it's bigger than -5, like -4, -3, anything bigger than -5 will work, because like -4 plus 5 is +1, that's going to work. So as long as x is bigger than or equal to -5, that would be the answer. So, sorry, this is not number 2. This is not. So on this one, the answer would be x is greater than or equal to -5. Okay. Number 2 is very similar to this. So basically you just say what x value would make this equal to 0. In this case it's -5, and you say x could be anything greater than or equal to that. And that would be the domain. That's all the x values that should work, that you can plug in with no problems. Okay, jumping to number 3, it's different. Number 3 is different because the -2 is not under the radical. It's not under the square root. So a -2 out here doesn't really affect whether this in here is going to be negative or positive. So what could x be? Well, just like number 1, x could be anything 0 or greater, because square root of anything 0 or greater works. So the answer to 3 is actually the same as number 1. Well, what about this -2? Doesn't that make it less than 0? Well, yeah, after you do the square root, it does. So if I plugged in 0, I get square root of 0 is 0, -2 is -2, so I'd have a point at 0, -2. That's okay, that's a real solution. As long as the -2 is not under the square root, it doesn't matter. So 1 and 3 are the same answer. Okay, number 5, it's kind of like number 2. It says x minus 5. Only difference is it has a minus under there. So what x value do we need to at least make this value under the radical a 0? What x value would make this 0? What minus 5 is 0? 5. So if this is at least 5, then the value under the square root should be at least 0. So that would be good. So it needs to be at least 5. How do I write at least 5? Greater than or equal to 5. Okay, it's going to be greater than or equal to every time on these. All right, I take that back. There's a couple weird ones. Number 7. Okay, 8's the only weird one. So I'm going to have to talk about 8. Seven says x plus 2 minus 3. Okay, just like number 3, it doesn't really matter for the domain that this minus 3 is out here. It's not going to affect whether there's a negative under the square root. Only this plus 2 is what we have to worry about. So just like number 2, what x value would make this 0? What plus 2 equals 0? -2. So x would have to be at least -2. Okay. Number 8 is weird because they put a negative under the square root. I always sneak one weird one in on me. And that's going to change things a little bit. If I plugged in 0, -0 is just 0, that would work. 0 is fine. But if I plugged in, let's say, a positive 1, then I would have negative 1 square root of negative 1, which is, imagine, not real. Okay? Something weird. So a positive 1 in this case doesn't work. If I plug in positive 2, positive 3, all those won't work because they turn into negative 1, negative 2, negative 3. So all the positives on this one actually don't work. So everything's kind of backwards. 0 still works because it still makes a 0. What if I plug in a negative 1? Well, negative 1 is actually positive 1. So in this case, everything's backwards. Negatives work, positives don't. Because that negative out in front just switches everything around. So 0 and everything negative works. How do I write that? Well, everything less than 0 is all the negatives, and that includes the 0. So number 8 is the only one in 1 through 8 that is like that, and I gave it to you guys, so that is number 8. Okay, we're skipping 9 through 16. I actually did 9 on the board earlier with the graphing. I know it's kind of hard to graph with that nicely without graph paper, so we'll just use 17 through 22 to talk about the graphs and move on. Okay, I mentioned kind of how 17 through 22 is going to work earlier. It's going to follow the same rules that the x squared graphs followed. 17 is the example I did on the board that I erased a long time ago. It's just okay, you guys recall that? It's just the basic square root graph where it kind of flattens out. It will still go up, slowly climb forever and ever, but it's going to climb at a slower and slower pace. Still going up forever. So that option, this is multiple choice, the matching on 17 through 22. So which option matches number 17? Looks like A, the first option. So 17, you can just put A at the end. Okay, on 19. Okay, looks like 18 and 19 are kind of similar looking. 19 has the plus 2 under the square root. Looks like this. Okay, recall that when there is a number next to the x, that's kind of like back when we did these functions, the quadratic, the squares. Kind of the same idea here. What happened on these functions was when you put the number directly on the x, it shifts the graph left to right, but it does the opposite of what you might guess. So plus 2 actually moves the graph left 2. On a square root, does the exact same thing. So if the function normally looks like this, if we move it left 2, it would now look like that. Okay, so we're trying to find a graph that looks like this back one here. And that would be option, looks like D. So number 19 is just D. Now 18 does the opposite. I know this is another even, but whatever. 18 puts it out here. Now the number, when it's outside of the square root, that's kind of like this, okay? What happened was it affected the up and down, the y value, and it does exactly what you would guess it would do. So plus 2 actually moves it up 2. So plus 2 would move it up 2. So you're supposed to match, this graph would move up 2, so it would be like this. So find the one that matches that. Okay, number 21. Okay. Says all right. On 21, the Negative is out here. Let's just plug some numbers in and see what would happen. If I use that table from before, if I plug in 0, if I plug in 0, I get 0, negative 0, 0. If I plug in 1, square root of 1 is 1, negative 1. If I plug in 4, square root of 4 is 2, negative 2. And whoops, and this would be negative 3. So what I'm getting is all negative values on the y. So what's happening is it's kind of an upside down version of what it was. So the negative out in front just flips the graph upside down. So that would be E for number 21. 20 is kind of the opposite. It's the negative is inside the square root. We kind of talked about number 20 on number 8. They both are the same function. Only the negative x values are going to work, because when you put a negative in front of it, it's going to make negative values positive. So it would look more like this. So if I plug in 0, negative 0, 0, square root of that is 0. If I plug in negative 1, it's positive 1. If I plug in 4, it's positive 4, square root of 4. Plug in 9, square root of 9. Okay, so on this one, the weird thing is all the x values are negative. So what's going to happen is you go negative 1, 1, it's over here. Negative 4, 2 is over here. So what's happening is it's actually just going to go backwards. It's just flipping from going left to right to left. So that's number 20. Just got to match that one with the answer. And 22, there's not really a trick on 22. The minus 3 in the square root moves the graph right 3, and the minus 1 outside of the square root is going to move the graph down 1. So anyway, it's kind of a short assignment. I know we're probably rusty on that. Hopefully you guys didn't forget those tricks. So that's all for page 478.